Hello everyone, I'm Vincent Schonewood and together with Steven Fleuren and Joost Olimans I will present the Huygens webinar on Whatsnew in Huygens 22.04. So let's start with giving a short overview with the Object Analyzer, and the Object Analyzer will be further explained in a few minutes by Steven. So we've added to the Object Analyzer improved watershed segmentation. We've added tools for cluster analysis, and there are now more coloring options for objects. Then Joost will proceed with the new lookup table editor, and this lookup table editor is present in the slicer, in the twin slicer, in the MIP renderer and in the twin MIP renderer. And with this editor you can map intensities to colors. You can optimize your data visualization using advanced LUT editing tools, and you can load, view and edit existing LUT files. Then in the object tracker we added a spider plot, so you can plot the object paths with respect to their origin. And we have a new license window under the Help License Manager menu, and here you see an overview of all the options in Huygens and the ones that you have, with web links to the respective websites. For more information on what's new in Huygens 22.04, I'd like to refer you to our website svi.nl/whatsnew. So let's start with Steven.
Thank you, Vincent. Next I'm going to show you some new features in the Huygens Service Renderer and the Huygens Object Analyzer. To start with, I'm going to show you about what we did to improve the segmentation in those two tools. On the left here you see an image that's successfully segmented with the basic threshold and seed segmentation algorithm that both of the Huygens Service Renderer and the Huygens Object Analyzer have. But on the right you see an image where the standard Huygens, the standard threshold and seed method is not good enough, because the three cells that you see here are still connected to each other. But before, to solve this problem, we usually would use the watershed segmentation. However, before our latest version, that would provide an image like this, where the cells were overly fragmented. In the 22.04 release we have solved this problem by adding a new fragmentation parameter, and as you can see, with this new fragmentation parameter you can set that to 50%, and then you get a good segmentation for this image. And we also made some other improvements to the watershed algorithm. For instance, you can now set, instead of garbage volume, you can set a minimum object volume, and then it will merge these smaller objects into large objects instead of discarding them like it did before. Alright, so that's it for segmentation for now. Next I'm going to tell you about some Object Analyzer specific new features. First I'm going to tell you about new coloring options. So what we have is you can now adjust how the objects are colored based on analysis results that you have achieved in the Object Analyzer. So to give an example, in this image on the left we have measured the distance from the mitochondrial objects to the central nucleus, and then we have selected to be coloring based on this parameter. So what you then get is that the objects that are near the central nucleus get a different color than the objects that are very far away. Currently there are a few parameters that you can use this on, that you can use to get this kind of coloring. So for this image you use the distance to the surface of the region of interest, but you also have the option to get, for instance, the label is just the default coloring, where it's just based on the label that the objects got. But you can also based on color based on how many voxels there are in an image. So then larger objects will get a different color than the smaller objects. You can also color on based on clustering. So this is also something new. Clustering is something totally new, so I'll get back to that later. And you can also color on some things based for localization. So for instance, when you have large objects, a few large objects, and in the other channel you have some smaller objects that are inside those large objects, then you can each of the smaller objects the same color as the large object. Lastly, you can color on the distance to the ROE. So likely we'll still expand this list in further updates to give you even more flexibility in how you want to color your images. So lastly, I've talked about the new cluster analysis features in the Object Analyzer. I also will give a short demonstration about this in a few minutes. First, I'll give a short summary. So what you now can do is you can use something called the DB scan algorithm to group objects that are near each other and form groups together, and then they'll each get a different cluster number, and you can use that, for instance, for visualization, so that different groups of objects get the same color, and you can also generate statistics about each of these individual groups. So for instance, in this table I have analyzed an image that was split up in 5 different clusters, and here you can see some of the basic properties of these clusters. Mostly importantly, it will report how many objects there are in each cluster. But of course you can also still get statistics of these individual objects if you want to. So then now I'll continue with a short demonstration of the Object Analyzer, in which I'll show some of the how you can use the new watershed and visualization options, and I'll also give a bit more information about the cluster analysis. So I'll now continue with a short demonstration of the new features in the Object Analyzer. To do this, I've loaded this image, which shows some mitochondria networks. So you see as objects is a stat channel that has been decomposed with Huygens, and in the background you see a confocal channel as a MIF rendering. So the first thing I'll do is I'll go through the segmentation tab on the right to point out what's new there. So the first thing is this the Gaussian filter. So I haven't discussed this before, but we have now we already had the Gaussian filter in the Object Analyzer, but before you could only use it when you also used watershed segmentation. And now you can always use this Gaussian filter, and what this does, it will create somewhat smoother objects, which I'll show you. So you'll see in the rendering, you see that objects now have much smoother boundaries. The next, what's a little bit new, is this minimum object size, which we used to call garbage volume, but now because it behaves slightly different in the watershed segmentation case, we renamed it. But what's also new is that you can now specify the value in metric or in voxels, so you can choose now which you would prefer. The next, as I told you, the watershed set segmentation as a new parameter, fragmentation, which you can set here. So you can create very low fragmentation where objects are very large, or you can set very high fragmentation where objects are much smaller and more split. Then next I'm going to show you the new cluster analysis tools. So to use those, you have to open this menu with this button here. And then you'll see a window with some explanation about the new cluster analysis and a few parameters. And below that you see the buttons that actually apply the cluster analysis. So I'll first give you a preview of what you kind of would expect. So what happens here in the rendering, all objects that together form a bit of a group because they're very densely packed together, are assigned the same color. So these are still separate objects, but they're grouped into a single cluster. And to get these clusters, we use an algorithm that's called the DB scan algorithm. And that algorithm simply needs a few parameters to know how to cluster, which we do automatically estimate, but you can also change them if you want to. For instance, by increasing this distance parameter, I can make the clusters larger. So to do this, I first have to disable the automatic estimation, and for instance, if I increase this, for instance, to let's say to 0.45, then you see that some of these clusters are now merged into a single cluster. Or if we go a bit lower than that, but a bit higher than before, we now have all the different groups were nicely separated. So this one is also a standard parameter of the DB-scan algorithm, which you usually would not really touch unless you really know how this DB-scan algorithm works. This one is this one you can use to set a minimum number of objects in each cluster. So for instance, if I set this to 10, you'll see that a few clusters become gray, and gray here means that they're not part of any cluster. So these ones are now in DB-scan you call those noise points. And then lastly, once you're done and you're happy with the result that you got from your preview, you can press finish and close, and then you can go take a look at the table. So in the table you now see a few new rows that weren't there before, namely the cluster rows, and these give the statistics of the full group of objects. And in this column here you see the index of this cluster, and that's also provided in all of the objects are inside that cluster. And you can also, if you only want to look at the cluster rows, then you can also now disable the object entries, and then you could only get the cluster rows. Or the other way around, you can also remove the cluster entries if you want to. Oh, and lastly, I want to show you the new visualization tools. So currently all the objects are colored by their cluster, but for instance you can also go to this step here and then go back to the old labeling coloring, or you can for instance color the objects based on how large they are by selecting the voxels option, where then the blue objects are largest and smaller objects are colored red.
Thank you, Steven, for this overview, and let's move on to Joost.
Hello, My name is Joost Oliemans. I'm a developer at SVI, and I'm going to do a short demo of our new lookup table or LUT editor today. With lookup tables, you can define a custom mapping between image intensities and colors. Let's take a look at what that means in practice. I've loaded a 3D image of a macrophage with 3 channels, which may be familiar to some long-time users of the Huygens software. To use the LUT editor, we must first open a rendering tool such as the slicer or the MIP renderer. For this demonstration, I will make use of the maximum intensity projection or MIP renderer. Under the default settings, intensities in each channel are mapped to their emission wavelength, so that we are presented with a somewhat natural image. However, we can use the color mode selection box to change the way in which the intensities are mapped, for instance to a heat map. Note that for many mappings, using multiple channels can result in unexpected coloring and even clipping of colors. To reduce these effects, lower the number of channels or simply adjust the brightness. We will now select the option Custom Lookup Table, and note that a widget appears next to the selection box. Click this widget to launch the lookup table editor. This is the main interface of the lookup table editor. Note that there is a large graph representing our lookup table in the middle of the screen and a colored wedge at the bottom, giving us a visual representation. We will now go through each option step by step. At the top left, there is a selection box which we can use to choose which channel slot we want to edit. We can use it to define a different lookup table for each channel, or click the button below to apply one channel's lookup table to all other channels. We can take a closer look at how this works by selecting a preset LUT from the selection box beside it. This selection box can be used to load any of Huygens' default lookup tables. By default, loading a preset LUT will apply to all channels, but we can also deselect this option by clicking the check button below. We now load the heat map from the presets. Note that the name in the selection box to the side has changed and that our rendering is now colored like a heat map. Using the selection box at the top left, we can see that the other channels are also set to the heat map. If we would like our first channel to have a different preset, we can select that channel, deselect the Apply Preset to All Channels check button, and simply select Gray, for instance. We can also save and load lookup tables. Let's visualize just one of the images channels with a lookup table that I have previously prepared and saved. This lookup table maps low intensities to blue, then slightly higher ones to magenta and red, then orange, and finally yellow and white. However, as we can see in the graph, in the wedge visualization below, and in our rendering, for some reason the lowest intensities are being mapped to white and the highest intensities to black. This causes undesirable artifacts in our image. Selecting the relevant control points in the graph, we can drag and remove the control points that cause this. Alternatively, we can use the middle mouse button to delete individual control points. If we want to make further changes to the lookup table, we can drag existing control points or select the color cursor we want to edit above the graph and click at any position to add a control point. Then we can use the Delete Last Control Point button to remove it again. You may notice that this lookup table has an inconveniently large amount of control points. Clicking the Simplify Lookup Table button automatically removes all control points that contribute little to the overall look of our lookup table. If we want to start anew, we can simply click the Clear Lookup Table button. Let's now try and reproduce the standard heat map by ourselves. Instead of adding control points to the graph directly, we will use the Gradient tab on the right. In this tab, we can select a starting and ending color and a range of lookup table slots and apply a gradually changing color gradient to this range that starts at the first color and ends at the last color. Let's select a range in the colored wedge below. Simply click, hold and drag with the left mouse button. Next, we select the first color by clicking the color wheel and selecting black. In the same way, we can set the second color to red. Now we click the Apply to Selection button to add our gradient. A heat map typically goes from red to yellow. We can select a new range in the wedge below, or simply enter the range we want in the selection entries here. For convenience, we use the swap button to switch the colors around, so we only have to set the second color. After applying, we can see that we have retrieved a lookup table that is almost identical to the standard heat map. There are some final options of note found in the Graph tab. By changing the plot mode, we can change the interpolation between control points from linear to a cubic spline. This can sometimes result in more natural looking lookup tables. We can also change the total number of control points, either setting it below the current value to remove those control points that contribute the least to our lookup table, or setting it higher to introduce new control points. Finally, by clicking the Enable Histogram check button, we can toggle the display of a logarithmic histogram of the channel's intensity values in the background. This was the Huygens webinar on the lookup table editor. I hope this helps you get started in this new tool.
Thank you, Steven and Joost, for the nice overview. I'd like to end this webinar by thanking everybody who contributed with their nice images, and refer you to our email address info@svi.nl if you have any further questions. Thank you very much. Have a nice day. Bye bye.